Have you ever wondered how a 2,000-year-old building could be stronger than anything we build today? The Pantheon in Rome has stood for nearly 2 millennia. Earthquakes, fires, barbarian invasions, 1,000 years of total neglect, and it still holds the record for the largest unreinforced concrete dome in human history. Strange, isn't it? The Romans had primitive tools, no electricity, no supercomputers, and yet they built something we cannot replicate. Conspiracy theorists have a simple answer: lost technology, ancient aliens, Atlantean knowledge smuggled out of Egypt. And honestly, when you see what's inside that dome, it's hard to blame them. But in 2024, engineers at MIT cracked one of 3 forgotten secrets. And what they discovered is more shocking than any conspiracy theory. By the end of this video, you'll understand why the most advanced building in Rome wasn't built last year. It was built 2,000 years ago. Picture this. The year is 126 AD. Rome is at the absolute peak of its power, an empire stretching from Scotland to the Sahara. And at the center sits one man, Emperor Hadrian. He wants to leave behind something that will outlive every monument in human history. So he chooses to rebuild a temple. The original Pantheon, built by Marcus Agrippa around 27 BC, had burned down twice. Hadrian doesn't just want to restore it. He wants to redesign it from the ground up. And his design is, by every standard of the time, mathematically impossible. Here's what he asks his architects to build. A perfect hemisphere of concrete, 43.3 meters wide, suspended in the air. No supporting pillars inside. No iron rebar, just one continuous shell of stone, heavier than the Statue of Liberty, hanging above the heads of every person who walks inside. His architects tell him it cannot be done. They show him the calculations. They beg him to reconsider. He doesn't care. To truly understand the scale of his madness, know this: the Pantheon's dome would remain the largest in the world for 1,300 years. 13 centuries of human progress, and nobody could match it. The record wasn't broken until 1436, when Filippo Brunelleschi built the dome of Florence Cathedral. And even Brunelleschi had to camp inside the Pantheon for years, measuring every angle, trying desperately to reverse engineer what the Romans had done. He never fully solved it. Neither did Michelangelo when he designed St. Peter's Basilica. In fact, and this is the part that drives modern engineers absolutely insane, no major dome built in the last 2,000 years has matched the Pantheon's structural elegance. Every modern dome cracks. Every modern dome needs steel reinforcement. The Pantheon has none of these problems. After 2,000 years. So how did a man without electricity, without modern cement, build something we cannot replicate? The answer lies in 3 discoveries Hadrian's engineers made, which were completely forgotten for almost 2,000 years. The lead architect was almost certainly a Greek-Syrian engineer named Apollodorus of Damascus. Apollodorus had designed Trajan's Forum, the largest in Rome, and a bridge across the Danube that allowed Roman legions to conquer modern Romania. But the Pantheon was his masterpiece, and it nearly killed him. Construction lasted 6 years. Several of his calculations were proven wrong by reality. Scaffolding collapsed. Workers died. 3 different concrete mixtures had to be designed from scratch. Hadrian and Apollodorus eventually had a bitter falling out. The emperor had Apollodorus executed for laughing at one of Hadrian's own amateur design sketches. A petty end for a man who built something no other engineer in 2,000 years has ever matched. Now let me show you the first secret of his impossible building. In January 2023, a research team led by Admir Mazik at MIT published a paper that shocked the engineering world. For decades, scientists had assumed that the small white chunks visible throughout Roman concrete were just impurities, sloppy mixing. Mazik's team proved the exact opposite. Those white chunks weren't accidents. They were the secret ingredient, the single most important discovery in concrete chemistry in 50 years. Here's what the Romans did. They used a technique called hot mixing. They combined quicklime, calcium oxide, fresh from the kiln, directly with the volcanic ash, while the lime was still hot enough to drive the reaction at high speed. This created tiny chunks of unreacted lime embedded throughout the concrete. Modern engineers had spent decades trying to eliminate these chunks. Roman builders deliberately put them in. And here's why this matters. When a microscopic crack forms in the Pantheon's dome, water seeps in. The water reaches one of the lime clasts. The lime dissolves, recrystallizes inside the crack as calcium carbonate, and seals the gap. The Pantheon literally heals itself. In Mazik's lab, Roman-style concrete repaired cracks up to 0.5 millimeter wide within just 2 weeks. Modern Portland cement? It just propagates the crack until structural failure. Now, here's where the conspiracy theorists go absolutely wild. How did the Romans figure this out? Without modern chemistry, without electron microscopes. The alternative history community has a simple answer. Someone taught them. Some say it was Atlantean refugees who survived the Great Flood, smuggling lost knowledge into ancient Egypt, then to the Greeks, and finally to Rome. Some go further. Ancient aliens, visitors who shared technology in exchange for the construction of pyramids aligned with the stars. When you look at the precision of Roman concrete, the deliberate inclusion of these microscopic self-healing chunks, it's tempting to believe. But the reality is somehow even stranger. The Romans didn't have modern chemistry, but they had something we've forgotten. Centuries of patient, generational observation. Master builders teaching apprentices for decades. Multiple failed attempts. That's almost more impressive than aliens. The second secret is the volcanic ash itself. Pozzolana, from the town of Pozzolana near Mount Vesuvius. Reactive aluminosilicate ash, with chemical properties we still don't fully understand today. When you mix pozzolana with lime and water, you get aluminum tobermarite, a rare crystalline structure that grows slowly stronger. For centuries, Roman concrete doesn't just last longer than modern. It actually gets stronger as it ages. The third secret is more impossible. It has to do with seawater. In 2017, geologist Marie Jackson from Utah analyzed Roman marine concrete, the stuff used to build ancient harbors. They expected degradation. 2,000 years of salt water. There should have been nothing left. What they found shocked them. The seawater hadn't weakened the concrete. It had actively strengthened it. While modern concrete piers in Florida crumble after just 30 years, Roman harbor walls at Caesarea Maritima are still structurally intact after 2,000 years. Stronger than the day they were poured. Every modern concrete structure on Earth is slowly dying from the moment it's built. Roman concrete is doing the opposite, slowly becoming more permanent. The self-healing concrete is incredible, but it doesn't actually explain how the Pantheon stands. Because the real mystery isn't the chemistry, it's the geometry. The Pantheon's dome weighs approximately 5,000 metric tons. The weight of 1,000 African elephants, suspended in the air, held in place by nothing but the structure of the concrete itself. Modern engineers would solve this with steel rebar. The Romans had iron, but they almost never used it for structural support. Iron rusts. Iron expands and contracts. So how do they distribute 5,000 tons of weight across an open span of 43 meters? The answer is variable density concrete. The Pantheon's dome isn't made of one uniform mixture. As you move up from the base toward the oculus, the concrete gets progressively lighter. Near the base, where the load is heaviest, the Romans used heavy travertine limestone and dense volcanic tufa. In the middle, lighter materials, crushed brick. Near the top, pumice, volcanic foam, so light it floats on water. The dome's center of gravity is shifted dramatically downward. The structure supports itself the way a stone arch does, through pure compression. No tensión. No rebar. But it gets more sophisticated. Look up inside the Pantheon. You'll see 5 rows of recessed squares, coffers. Most tourists assume they're purely decorative. Each coffer removes a precisely calculated amount of weight from the dome, 300 metric tons total, without compromising structural integrity. The Romans were doing finite element analysis by hand with wax tablets 2,000 years ago. And then there's the oculus, that circular hole at the top, 9 meters across, completely open to the sky, is not a weakness in the design. It is the keystone. In any traditional arch, the keystone locks all other stones in place through compression. The oculus serves the same function, but for a 3-dimensional dome. The ring of compression around the opening transfers force outward and downward, distributing the weight evenly. Remove the oculus, and the dome would actually be weaker, not stronger. When it rains in Rome, the Pantheon doesn't flood. The dome is designed to channel water outward through 22 invisible drainage holes in the marble floor. Every detail was thought through. Every angle, every material choice, every drainage path. When you stand inside the Pantheon today, you're standing inside a single, continuous physics experiment. 5,000 tons of stone hanging in the air above your head. For 2 millennia, and counting, the construction industry is in crisis. Modern concrete is responsible for approximately 8% of all global carbon emissions. That's more than the entire aviation industry, more than all the world's cars, trucks, and ships combined. And modern concrete buildings have a structural lifespan of just 50 to 100 years. After that, they crack. They have to be torn down and rebuilt, generating millions more tons of carbon emissions. Roman concrete lasts thousands of years, with significantly lower carbon emissions during production. The Romans were essentially carbon-negative builders 2,000 years before climate change became a concern. If we could fully reverse engineer Roman concrete, we could revolutionize global construction. That's why MIT's research has attracted hundreds of millions of dollars in private investment. Companies like DMAT Technologies in Massachusetts, CO2 Concrete in California backed by Bill Gates, and Forterra in the UK are racing to commercialize Roman-style, self-healing concrete. The first commercial applications enter the market by 2027. By 2030, self-healing concrete could be standard in critical infrastructure projects across Europe and North America. But here's the strangest truth. Even when we crack the chemical code completely,